Alright, so we're going to be doing two last topics to be able to graph something called a rational function. And to be able to graph rational functions, we need to find asymptotes. So here are some key terms. What is a rational function? Well, it's a function in the form p of x over q of x. Here are some examples. So it's basically a fraction. And if you notice, we have polynomials in the top and in the bottom. But this is what a rational function is. So we're going to be graphing these. And to be able to graph these, we need to be able to find our asymptotes. Now I know last year you did find asymptotes. What is an asymptote? An asymptote is a line that the graph of the function approaches. So you'll have this vertical or horizontal asymptote. The graph will come towards it, gets closer and closer, but it doesn't touch that graph. So we have different types of asymptotes. One type of asymptote that we are going to find is a vertical asymptote. So we want to make sure the function is always in lowest terms before we find the vertical asymptote. And all we need to do this is to get our denominator, make it equal to 0. If you factor it, factor it. If not, you just solve it for x. So here are two examples of two rational functions. And we want to find the vertical asymptote. So looking at this one here, 2 over x plus 3. Can't simplify that anymore. So to find the vertical asymptote, which I'll abbreviate as VA, we're going to take our denominator, make it equal to 0, and solve it for x. X equals -3. So our vertical asymptote for this example here is x equals -3. So it's going through the x-axis through -3. Okay, second example, 4x over x squared minus 4. This one also, we're going to find our vertical asymptote. Can't cancel anything here because the 4 is attached with the minus here. Can't cancel this with this again because of the minus. So we're going to make our denominator equal to 0 and solve this one for x. Add the 4. And what do we do to get rid of a square? We're going to do square root. And we have two possible answers for the square root of 4. We could have x equals 2, or we could have it as -2, right? Because -2 times -2 does give us +4. So the vertical asymptote for this example are those two lines, one going through 2 and one going through -2. Second type of asymptote is a horizontal asymptote, horizontal line. Alright, here we need to look at the degree, meaning the highest power in the numerator and the denominator. So we're looking at the degrees here. So here are 3 different possible cases of the degrees. If the denominator has the bigger degree, your horizontal asymptote is this answer, y equals 0. So that's pretty easy there. If the numerator and the denominator have the same degree, divide the leading coefficients of the numerator and the denominator. So we're going to look at an example for that one. And then the third case for a horizontal asymptote is if the numerator is the bigger degree, then the graph will have something called an oblique asymptote. So it's a line, slanted line. And to figure out this asymptote, if the numerator has the bigger degree, we're going to use long division or, if possible, synthetic. Alright, so we have 3 examples here. Alright, let's first take a look at this one here. What is the degree of the numerator? 3x. Okay, this one has the imaginary 1 with the x, so that's a degree of 1. What is the degree of x plus 4? Well, we're looking for the one that has the highest degree, which is this one here. So, these are the same. So if the numerator and the denominator are equal, we're going to divide the leading coefficients. So what is the leading coefficient of this one? 3. What is the leading coefficient of x to the first down here? It's a 1. So for the horizontal asymptote, Your answer is always y equals, because it's a horizontal line going through the y-axis. So this answer is y equals 3. This is my horizontal asymptote. Let's try doing vertical here. What would be the vertical asymptote for this? This is in lowest terms, can't do anything about it. So we're going to take our denominator, make it equal to 0, and solve it. So my vertical asymptote here would be x equals -4. Alright, let's take a look at number 2. We've got x to the 3rd divided by x to the 4th minus 1. Okay, what is the degree of the top? It's a 3. What's the degree of the denominator? It's a 4. So that means the degree of the denominator is bigger. So that means this horizontal asymptote is y equals 0. Let's say I wanted to find my vertical asymptote for this one. I can't cancel these out because this is attached with a -1, so this is in lowest terms. So to find the vertical asymptote, we take our denominator always, make it equal to 0, solve this for x. And now, how do I get rid of to the 4th power? Well, I gotta take the 4th root of 1, meaning what multiplied by itself 4 times will give me 1. Well, definitely 1, and also -1. So those are my 2 vertical asymptotes. Okay, last one here. We're looking at this one, x cubed minus x plus 1 over x plus 1. Alright, I'm going to erase this. We are looking for our horizontal asymptote. So what is the degree of this top? Well, the highest degree here is 2. And what's the degree of the bottom? A 1. So that means the numerator has the bigger degree. So it's actually an oblique asymptote. So we need to use long division. Here we could do synthetic division because we're dividing by x plus 1. So let's refresh our memory about synthetic division. We need to write the coefficients. 1, -1, 1. And then on the outside, what are we dividing by? Well, we take that, right? Make it equal to 0. So we're dividing by -1 here. Alright, what was the process? Always the first one comes down. We multiply, 1 times -1 is -1. Add these two together, we get -2. -2 times -1 is +2. 2 plus 1 is 3. This last number is the remainder. So the remainder can't be the asymptote. The oblique asymptote here is this answer over here. So let's write this as our polynomial. If we started with x squared, we're going to go down 1 less. So this is a 1x minus 2. And remember, these answers for horizontal oblique are always y equals. So this is my oblique asymptote. These don't happen too often, the oblique ones, but when they do, you've got to do your long division or synthetic. What would be the vertical asymptote for this one? Well, if I take my, let's see, can I factor this anymore? Can this be factored? X squared minus x plus 1. No, factors of 1, that gave me -1. When I add is impossible. So this is in lowest terms, so we take our denominator, make it equal to 0, and solve it. So my vertical asymptote is x equals -1. So we're going to consider these asymptotes now when we start graphing these rational functions.